Hi, everyone. Good afternoon and welcome to our office hour for today. First off, I'd like to apologize for starting late, but we're here now and welcome, everyone. So the solution for week 4 I would do that tomorrow in our office hour tomorrow and not today because we still have some pending things, I believe, to cover in object-oriented programming. And I felt it best for us to do that today. Then we'll go through the solution for week 4's task tomorrow. Okay. Before we get started proper, let me go to the question sheet and see what you all have for me. Okay, so there's a question on class inheritance as to why we should override a method from a superclass in a child class instead of just creating a new method in the child. And then someone requested for the correction of week 4's task. So I already answered the second. So for the overriding of methods, we're going to cover that today. It's part of the it's in the schedule, right? So we're going to cover that today. Let me quickly share my screen. Today, we would not be using Dartpad. I moved over to my IDE, and that's where we're going to code from. That's where we're going to code from today. Let me quickly share that. Okay. Okay, we're here. Sorry, that took a bit. Oh yeah, we're here. So yeah, like I said, I'm going to be working off my IDE. I'm using Visual Studio Code. The essence of this is just so that there are some things that cannot be explained using Dartpad, and next week anyway, we're going to officially move on to using our IDEs, so might as well start now, right? All right, I already created a sample project. So we would not be going through, that bit. It's not part of today's session. So I'm just going to explain a few things, right? You know how we are expected to have, well, just as it applies in Dartpad, we're still expected to have a main method inside of our code base. It's pretty much still very important here. Without it, you would not be able to run your code. And it's essential that we have that. If that we always have that, right? I already cleared out the sample code that you'd see when you create a new Flutter application. So this is just us learning learning Dart and not Flutter. So in our last class, we covered inheritance. Oops, I think I need to zoom in so that you'll be able to see my screen. Let me confirm if, I thought as much. Okay. So sorry for that. I totally forgot. Let me see how it looks. Okay, I think that looks much better. Okay. All right, cool. So in the last class, we covered inheritance, and we said that when you create a parent class, say animal, if you were to create subclasses of this parent class, you would need to use, a keyword called extends, and then you extend the parent class just like so. Extending helps, gives us the opportunity to access the different methods and properties of our parent class within the subclass. It's essential to have, I mean, in cases where we would need a parent class is in a case where we have some primary features, for example, that we want our subclasses to have, instead of having to write each of those properties or methods individually inside of our subclasses or inside of different classes. You just need to create a parent class and then extend that parent class and just create subclasses of it. Like we did before, if if we had a method like so that simply prints stuff. Oh, I should have taken this out, this warning, but just ignore this. I would likely cover this when we officially get into Flutter. But for now, we have this method inside of our parent class that's simply prints stuff. We can easily access this method without even doing so much. I mean, without having to rewrite this method inside of the subclass, we can, when we create an instance, for example, of our dog class, even though we don't have the method inside of it directly, we can access print stuff of it because it extends this parent class that already has this method. Now, an ideal way to create a parent class is actually to use abstraction to make the parent class an abstract class, and then you can extend it, you can create subclasses of the abstract class. So the abstract class sort of serves as the well, aside being the parent class, it has as many signature methods that you would want to have within that abstract class, and then you can access or you can build on it in extended classes and subclasses. Here's what I mean. If you create an abstract class, the only difference between this and an abstract class is the abstract keyword, like so. So this makes our animal class here an abstract class. Now, to answer the question that was left using the form as to why we need to override a method instead of just creating a new method in the subclasses. Well, that's where, if we were to create an abstract class like so, we would have a bunch of methods inside of it that we can easily, or we can flesh out within our subclasses. So in this way, it's possible we want to print something. I mean, I'm just using this example here. Sorry that it's not as detailed as one would expect it to be, but we would probably want to print maybe something else other than stuff, like want to print instead of just the stuff string, want to print something else. And in that way, we can flesh it out in our different subclasses in whichever way that we want to flesh it out as. So you see here that there's an error that says missing concrete implementations of animal.print stuff and animal.print another stuff and print stuff. Try implementing the missing methods or make the class abstract. So because this is an abstract class, whatever method is inside of it has to be overridden or has to be implemented inside of the subclass. So so we have these, this is how it's supposed to look like, where we override each of the methods inside of our abstract class, and then we can put in whatever implementation that we want inside of it. So if we have maybe another class of cats that extends the animal class, we're still expected to override those methods, and we can flesh it out in whichever way that applies to our individual classes. So maybe in this case, what we want to print here is another dog. And here we want to print dog. I'm just going to copy this because it's pretty much the same thing. We're just going to edit some things inside of it. So here we want cat, and here we want cat. So this here, so this here, we simply have a main class here, the parent class with different methods, with two methods inside of it. Now, whenever we create a subclass, whenever we inherit this parent class, we can flesh out the methods that are inside of it. So it's just like a, what's the word? It's just like how you have an email signature, right? And then anytime, whichever time you compose an email, you always have that signature attached to the email that you're sending, no matter the body, no matter what is inside of it, but that signature is always going to be a constant. So this is like the signature of this class, and any class that you extend off this needs to have this attached to it, and then you can do whatever thing that you want to do inside of it. So if we have a method that says string display a name, for example, right? You see, like adding another method to this already throws an error for each of the subclasses because you're expected to overwrite them. Let's just take these two out because it looks funny. Printing stuff and printing another stuff. Okay, so we're going to override the display name method like so. Let's do the same for the cat class. And then inside here, we can choose to, you know, oops, it's returning a string. It's returning a string, so we can't just print it. I hope you all remember that part of functions and of objects in general, that whatever data type you declare it as has to be the data type that you return. Okay, so say this is, if I were to pass in an argument of name, it's not going to say I return name. This is going to be a problem because in our abstract class, when we declared this method, we did not state that it has any arguments. it's not expecting an argument, and then here in the override, I'm passing in an argument, and you get to see that dog.displayName and its argument isn't a valid override of animal.displayName. But if we're to add this parameter here, that somewhat solves our problem, no? If I were to change this and make it optional, it's also going to be the same thing. So whatever you're overriding has to have the exact same properties as what you have going on in the abstract class, else it's going to, screen. It wouldn't pass, right? So yeah. So we have this going on. This one is yelling at us because it's expecting a parameter like so. And then we can pretty much, maybe in this case, we want to return the name is name. So in this case, we just return the name. In this case, we want to return a string and then append the name. So the whole point is when you have an abstract class, you have signature methods inside of it. And then inside of your subclasses, you can override them and then flesh it out as in any way that you want to flesh it out as. The only important thing to note is whichever data type is being returned by your signature methods inside of the abstract class, it has to be the same inside of your subclasses, else you're going to get errors. I know I didn't state this, but it's important to note that when you're declaring classes, you need to start with an uppercase followed by the name of the class, right? You start with an uppercase and then you go on like that. If I were to replace this with a small letter, you'd see that there is a warning that says the type animal isn't an upper camel case identifier. So whenever you're declaring a class, you need to declare it with a capital letter, else it would not, you're going to get a warning. At the same time, it doesn't conform with the naming convention of classes in Dart. It's the same thing with variables. You need to follow through with the lower camel case. That is, you start a variable or a function with a small letter, and then every word that comes after it, you begin the word with a capital letter followed by a small letter. I don't know if that makes sense, but just as we have going on here, we started the variable with a small letter, and then A is just one word. So it's in capital letter, and then name starts with a capital letter followed by small letters. So please note that when you're naming your variables or your classes or your functions, that they need to follow lower camel case for variables and functions, and then it has to be upper camel case for classes. Please take note of that while you're working on your while you're practicing or through your learning. Okay, so through this we have covered abstraction, and we've also covered inheritance. So they kind of work hand in hand, because when you have an abstract class, you're expected to use inheritance to flesh out the body of your abstract class. You cannot create an instance of an abstract class, hence why you need to create subclasses of an abstract class. The benefit of having an abstract class is, the primary benefit actually is for testing and also to properly organize your code, right? It's easier to test an abstract class because it's easier, it enables faster and better testing, and it also helps in code organization. Here we don't need to have to manually create all of these all of the different methods that we want within our parent class here. We don't need to do that in in all the different what's it called, in all the different subclasses. We have it in the main class and the parent class here, and we can just override the method in each of the subclasses. It also kind of helps us to have an initial idea of what we want our class to do. So say, for example, we have this animal class, for example. I know the properties inside of it do not match with the class name. I'm so sorry. But ideally, it kind of helps us to set the path in which we want our class to go. Say an animal class, for example, we would want to maybe declare a name of the animal, set how many legs the animal has, maybe set the color and all that. In this case, we already have that blueprint here, would have listed all the different properties that we expect our main class to have, and then we can build it on inside of our different subclasses. So you could also on your own read more on abstraction, and you'd see some other benefits of creating abstract classes instead of just having a bunch of single classes everywhere within your code base. You should also note that Dart supports single inheritance. You can only inherit properties from one class at a time. I cannot do a class, I cannot extend animal and then go ahead to extend some other new class here, right? So just as you see with the error, each class definition can have at most one extends clause. So you can only inherit one class at a time, hence single inheritance. Okay, I'm going to go to the comment section now to be sure that we are following so far. We've covered abstraction, inheritance. Please confirm that so far everything is clear. Oh, no one is saying anything. Okay, I'm just going to go on. In the case where what we've talked about so far isn't clear, you know what to do. To leave a question, using the form, and I'll do my best to answer when in our next session. What happened to my screen? Oops. Oops. What happened? Sorry, let me find my, what is, okay, we're back. Awesome. So someone asked, can we see the output on your screen? I'm sure. And then, is abstraction just about the class? What about private object instance? Is that no abstraction? No. The whole idea of private classes is a different concept of OOP known as encapsulation. Just as the word implies, encapsulation is when you I'm looking for another word. I didn't plan to cover encapsulation today, so it's another word. It's pretty much hiding certain sections of your code, right? So in Dart, right, every file is known as a library. Every just here, if you look at the structure of the folders within your within the project, you see that you have the lib folder, which is pretty much the library folder. So every file that is declared, that is created inside of the lib folder is a library. Now, if you want to create a library that is hidden or that is isolated from the rest of your code base, then you make it private, hence you encapsulate that class. Here's an example. Remember, we tried to look into private objects in our previous class, but because of the limitations of Dartpad, we're not able to do so. So let's try it. So here, for example, okay, let's clear all these out. And then let's create a class and name it private class. If we have properties inside of it or methods inside of it, print name, for example. Even though we have declared this, we declared this as private using the underscore. So any class or variable or function that you see with an underscore is expected to be a private object. Now we can access this private, class inside here for a reason, and that's because this class was declared inside of this file. If I were to create a new file and say, name it encapsulation test like that, and then I take this out and I create it in a new file, then I come back here and try to access the file. It's literally nowhere to be found. I cannot access this private class that we have created inside of this file here in the main method. But if I were to remove this underscore and then attempt to access it, you see the file name right here. We can easily import that class inside of this file with no issues, because right now it is no longer a private class. But adding the underscore makes this hidden. It makes it isolated from other parts of our code base. And even though we already have the file imported, we cannot access this private class because it is private. So only classes within this file or only methods within this file can access this class as it is right now. So this is kind of the whole idea of encapsulation. It is great if you want to create a class where you want to create a standalone class, like an isolated class or an isolated object. Maybe it could be for testing purposes. It could be for it could just be some library within your code base that you do not want accessible. Say, for example, you're creating a package a Flutter package or a Dart package, and you want a certain file within your package to not be accessible to the public, for example, or something, you can easily just make it a private class by adding, like, you can just encapsulate this class by using an underscore. So this is different from abstraction. This is a totally different concept from abstraction. They're two different things. I hope that answers your question. I'm waiting for you to confirm that if that answers your question or not. Okay, great. So far we actually did we actually ended up covering inheritance. Again, we did an overview of inheritance. We also covered abstraction and encapsulation. Okay, so I think I might understand why you would confuse abstraction with encapsulation. Abstraction somewhat, in some way, actually hides certain parts of, only makes available to other classes what is essential. What I mean is, when you create an abstract class and then you create a couple of methods inside of it, if it's also possible for you not to, it's also possible for you to allow classes to override specific methods that you want them to override, or to access in general. You can do that with an abstract class, but it's also within the idea of encapsulation, because as long as you're making a variable or a method or a class, as long as you're making it private, you're encapsulating that object, and that is what encapsulation is about. It doesn't have to be a standalone concept in that you're creating a file simply to express the whole concept of encapsulation. I mean, each of the principles of object-oriented programming, each of them work, they all work together. So you could have encapsulation, you could have abstraction, you could have inheritance going on in one file, you could have them going on throughout your code base together. So it doesn't have to be like when you're trying to encapsulate, you do that in one file. If you are trying to abstract, you do that in another file, and make sure that they don't know. They all work together to make an object-oriented program, if that makes sense. Okay, I think the last concept of OOP is polymorphism, which we would cover tomorrow before we get into the correction for week 4. Let me confirm if it's actually polymorphism. Polymorphism. Okay, yeah, that's correct. It's spelled like this. Polymorphism. Oops. So we'll cover this in our next class, and then we'll do the correction of the task for week 4. So once again, if you're confused, if anything doesn't make sense right now, please do well to leave a question, and I will try my best to cover it in our next office hour. That said, if there are no further questions, we would be ending our session here today, and would continue from here tomorrow at 5. All right, guys, thank you so much for joining. Thank you so much for joining today's office hour. Jeremiah, I'll answer your question on Slack. I'll see you all tomorrow.